Episode 115 of the Rule Your Pool podcast. I'm your host, Eric Knight with Orenda, and I'm going to be honest with you, not a lot of show prep for this one, but it's okay because we at Orenda talk about this every single day. And the reason I'm doing this episode is because the questions continue to come in and the problems as a result of not understanding this continue to happen. In this episode, I think it's worth a deep dive into understanding calcium. It is the bedrock of water balance, in my opinion. And I'm going to make that case for you in this episode today. We as an industry tend to underdose calcium. And I want to get into that in this episode because a lot of the problems that we're getting this year on that helpline and on ask@orendatech.com or just submitting a question to ask.orendatech.com, which is our help center, and even podcast@orendatech.com. We're seeing all of your feedback, and we love it. Thank you so much for the feedback. And there's a common thread. Not enough calcium. Let's get into it.
Welcome to Rule Your Pool, the podcast by Orenda that explains and simplifies pool chemistry so that anybody, regardless of experience, can understand it. I'm your host, Eric Knight, bringing clarity to these subjects so that you can bring clarity to your water. If you're ready to rule your pool, then let's go.
Now, I realize this is not the first episode where we've spoken about calcium. We actually discussed calcium in many of our previous episodes because we talk about the LSI so much. If you go back, you can listen to episodes 6. By the way, I'm scrolling through this as I'm doing it, so bear with me. Episode 6, 21, 34, 41, and then the 5-part series was 48 through 52. And that was on the common calcium issues that you have. Episode 55, I know we talk about it there because standardizing pool chemistry, namely using calcium as the foundation for that. 59 on how to implement the Orenda program, also using calcium as the foundation for that. Episode 93, raising and lowering calcium hardness. And episode 104 on calcium sulfate crystals. And now this. We need to understand this because continually, when people send me problem pools, they'll send me a screenshot of the Orenda calculator, which is great, allows me to see the LSI and everything, pH sealing, all of it. And I see calcium less than 300. Now, if you're in Miami, Florida, I understand that. But I'm not just seeing it in Miami, Florida. I'm seeing like 210 calcium in Massachusetts. And I'm seeing 250 calcium in Oregon. I mean, colder climates. That's not nearly enough calcium if you want to maintain LSI balance year-round, which of course is our first pillar of proactive pool care. I'll say it again. In our opinion, calcium is the bedrock of water balance. So let's dive into that. There are 2 disciplines in water chemistry, water quality and water balance. Water quality is sanitization, disinfection, water clarity, making it look nice, oxidation, ORP, etc. And a lot of what we do at Orenda is on that side of the business. Our enzymes help with supplementing chlorine against the oxidant demand, specifically non-living organics. And phosphate remover takes phosphates out of the equation. And all those things are water quality topics. Water balance is about physical equilibrium. And we measure this using the Langmuir Saturation Index, or LSI. Now, there are some other indexes. And by the way, I just recently learned that the plural for index is indices. You're welcome. If you got nothing else out of this podcast, you learned that the plural for index is indices. So take that for what it is and impress all of your friends at your next dinner party. I know dinner parties are a big thing in the pool industry. Of the 149 of you listening to this, I want you to all take that gem with you. So we use the LSI. Now, there are other indices like the Reisner Stability Index, or RSI. And if you see it online, a lot of homeowners here are probably reading forums online that may refer to just the SI or the CSI. The CSI is the calcite saturation index or just the saturation index. Generally, those are referring to the LSI or almost identical. If you're balanced on the LSI, you're probably balanced on the other ones too. But let's just stick with the LSI because that is the international standard and that is what we use in our calculator. The LSI is the measure of the saturation equilibrium of calcium carbonate. So what does that mean? I've used the analogy before and I'll use it again in case some of you listening have not heard the other episodes. If I were to put sugar into a drink and stir it around, it'll dissolve. And I add more sugar, it dissolves. And eventually I add too much sugar and I can't get all of it to dissolve. And some of it just stays at the bottom of the glass. You've probably seen this before. Now, just stirring it or even shaking it is not going to do anything because the water is now oversaturated with sugar. So we're going to replace the word sugar with calcium carbonate. That's basically the LSI. If you have too much sugar in your drink, if you have too much calcium carbonate in those conditions, then you have a high LSI and you will have scale or you will have cloudy water or other symptoms where calcium carbonate is precipitating out of solution. Basically, the water is saying, I can't hold all of this calcium. I have to get rid of some because water's trying to get back into equilibrium. So it has to shed calcium to get back down into LSI balance. Now, on the opposite end, the low end of the LSI, and if you're using the Orenda calculator, it would be a red number on the low end. The water's actually hungry for calcium. And so it looks for it and it dissolves it and brings it into solution when it finds it. But if you don't have a cement-based pool and you have, say, a vinyl liner or fiberglass surface, water's still going to look for calcium and it may destroy your surface looking for it, hoping that calcium might be on the other side of that vinyl liner. And fun fact about vinyl liners, there is actually trace amounts of calcium carbonate in vinyl. It's a bonding agent, I think. Look it up. Pretty crazy. So it is in there and it actually increases the porosity and the vulnerability, I will say, of a vinyl liner. This is why liners fade. If they turn yellow, that's more chlorine and sunlight. But if they lose pigment, like pure white, and they just lose pigment, that's usually an LSI violation. And more porosity leads to wrinkling when there's temperature swings and other things. Maybe that's an episode or a series of episodes in the future. But for right now, let's stick to the LSI. Water only cares about equilibrium. We've said this in previous episodes because it's true and it's still true today. Water cares about equilibrium. Doesn't care about you, doesn't care about us, doesn't care if it's green. It just craves equilibrium. It's physics. And that is an equilibrium of calcium carbonate. Now, I said earlier about the glass that in those conditions, you are oversaturated. And what I meant by that is, what could we do to this water? What could we do to this drink to get more sugar to dissolve? And when I teach this in classes, a lot of people will say, dilute it. And sure, I could drink sugar water and fill it with tap water with no sugar and get that sugar to dissolve if we're being literal. In a pool, you could drain it and dilute it and replenish. That could happen. And there's some math there because you got to know what's coming back into the pool. But that's changing water. I'm asking, what can you do to this water to get that sugar to dissolve? And the answer is you can heat it up for sugar. If you've ever seen sweet tea made, I live in the South, they're almost boiling water when they add all that sugar to it because you can't do it at room temperature. Same water, same amount of sugar being added, and yet the saturation point is so much different. And so if we take that concept to swimming pools, now we're talking about calcium carbonate, which actually dissolves better in cold water, not warm water. Almost everything else dissolves better in warm water. Almost everything else dissolves better in warm water, but not calcium. Calcium is more soluble in cold water. And that's a really important distinction to make because as the temperature of the water decreases going into the winter, the LSI is also decreasing. It's becoming more aggressive. The water is hungrier for calcium. That's why we advocate for having more calcium, especially in colder climates. You need that insulation because that's what the water's craving. As that temperature changes, the water wants more calcium. So either you give it the equilibrium that it craves, or the water's going to have to find it. Now, we talk about these conditions, and we could go ad nauseum about the LSI. I would recommend listening to the first 12 episodes or so of this podcast, where we go through each factor and talk about it in general. But there's 6 factors, and if you use borate, 7. You can change a lot of those factors, and if you factorial 6, that's 720 different combinations of numbers. Multiply that by the amount of numbers on each of the dials on the Orenda calculator, and you literally have millions of ways to balance water. Water has 2. If it's out of balance, water has 2 ways to balance itself. And while you may ignore the LSI, water can't. It's not like water just, I'd like to be balanced. No. Water has to be balanced. It's physics. So it either eats or it scales. If it doesn't have enough, it eats. And if it has too much, it gets rid of it and it scales. Whether that's cloudy water or scale on the tile line or calcium flakes in a saltwater pool or in the heater, whatever it is. That's why calcium's so important. You want to keep that equilibrium. And in order to do that, you need enough of it. And a lot of people will look at scale and they'll think, I don't want that much calcium because I'm used to having scale and I just have too much calcium in the water. And that's usually not the case. Now, it can be sometimes. But in our experience, it is rarely the driving factor behind scale. When we see scale, it is almost always a combination of too much alkalinity, which then drives the pH up, so that you have both a high pH and a high alkalinity. That is almost always the reason that you have scale in a pool. That is almost always the reason you have flakes in a saltwater pool. Too much alkalinity, driving the pH too high. Because if you play around on the LSI calculator, the pH has a massive impact on the LSI, and it moves. This is why we've devoted so much of our teachings in the last several years to containing pH and understanding Henry's law of differential pressures. We need to understand Henry's law because it's happening whether you like it or not. It's as guaranteed as gravity. We need to understand that if we don't contain the pH is going up anyway. I love asking this question in classes. If you have 80 to 120 alkalinity and you don't have an auto cover, you don't have a trichlor feeder, and you don't have an acid feeder, nothing fancy about it, it's just a pool. Have you ever been able to keep the pH below 7.8 after 7 days? And the answer is always no. Because you can't. The alkalinity is too high. It drives the pH up. Try it on the Orenda app. Plug in 80 to 120 alkalinity. Look at the pH ceiling. Just click at the top left, show secondary readings. Is that number above 7.8? Sure is. Now, if you have really high cyanuric acid, because you're using trichlor or whatever, sure, you come back after 7 days, and it's not going to be as high. Because you're lowering the carbon and alkalinity, you are lowering the pH ceiling. What we're advising you to do is have a little bit less alkalinity to minimize how high that pH ceiling goes. In order to have that lower alkalinity, we have to have more calcium to offset that on the LSI. It's okay to have more calcium. Everything in moderation, right? I'm not telling people in Tucson, you need 600 calcium. No, you don't need that in Tucson. But boy, could the people in Traverse City, Michigan use it, especially going into the winter. Through field experience alone, and please understand, people don't call us about their good pools very often. They're calling us for help with a problem, so our experience is really dense with problem pools. And most of those problems, especially with anything calcium related, etching, discoloration of plaster, or anything like that, it's almost always from a lack of calcium. Now, that may not be the only problem, but it is certainly one of them. And why is that? I don't know where it came from. This is just Eric speaking here. Where did we get the idea that 250 is optimal? I've never seen that in a book. I know the books say 200 to 400, but who picked 250? It seems kind of arbitrary. At least pick 300. It's right in the middle. That I would understand, but 250, no. I don't want you to be one of those people calling about the same old problems. Take a critical look at the calcium on all of your pools. If we go back to scrolling again, episodes 55 and 59 of implementing the Orenda program and standardizing pool chemistry, you're going to pick a calcium that works for you across all of the pools you service. And if you're a homeowner listening to this, ask yourself the questions: how cold does your water get? If your pool freezes, you're going to need more. If it never freezes because you're in South Florida, okay, you don't need nearly as much. The temperature doesn't justify it. The big question I always get is, what is the ideal calcium hardness for my pool? That's what people call and they ask, or they email. And the answer to that is, the ideal calcium hardness to rule your pool is whatever allows your water to stay LSI balanced year-round. This includes containing pH week to week so that you don't have an LSI violation. This also includes winterization off-season, whether you winterize or just have a cold season. And you may have two, by the way. You may be in the Northeast and you may bump it up intentionally to 500 something because it's going into the winter. And then dilution from rain and snow happens during the winter and you come back and you might have to adjust a little in the spring up to maybe high 300s or 400. So there might be two. But in general, the ideal calcium is whatever allows your water to remain LSI balanced 365 days a year. It is the foundation. You don't want too much alkalinity because it's going to raise your pH too much. But calcium doesn't really move. When it's in there, it's there. Water loves it. I'm not saying get crazy with it. Too much of a good thing becomes a bad thing, like anything. It just depends on where you are. So I'm just going to throw some quick numbers at you just to give you a concept, and we do have this on our website as well. Let's say you're in a really hot climate that doesn't get cold during the winter. So I'm just going to use South Florida, Houston, Texas, that kind of thing. Well, although Houston, Texas did have a freeze, so that was kind of an anomaly, but we'll use South Florida, that kind of climate. You probably want to have mid to high 200s on calcium hardness, maybe 300. That's probably appropriate. In the summertime, in a very hot climate that does have a winter though, like Phoenix, Arizona, or Tucson, or Palm Springs, those kind of areas, Houston again, you probably want low 300s on calcium. Just check on it because I know in Phoenix it can get cold. Water can get down into the 50s or even the 40s. So be careful on that. Let's say we go up to Northern California, mid to high 300s, maybe low 400s, year round. Of course, you're going to have more going into the cold, right? So most people are going to be adding calcium in the fall and then checking it and making slight adjustments in the spring based on dilution. In the Midwest, you're going to need a lot more because your pools are all going to freeze. So I would say in the summertime, I mean, you're in the 400s already. And then in the wintertime, get over 500 before you winterize. Same with the Northeast. I live in Charlotte, North Carolina. I've aimed for 400 and it's hot. I mean, it was 90 some degrees. It's summertime and I don't have any scale. Now, granted, my number's a little bit lower now because we had a good week or so of rain, and I'm going to test that now that I'm reminding myself, probably test it tomorrow, and I'm going to need to re-up that. But the point is, I want low 400s in Charlotte, North Carolina. In Georgia, you probably want to be high 300s, low 400s. And then going into the fall, again, raise it up. Don't be afraid of these higher numbers because how this is going to be managed is by having a little bit less alkalinity. And that depends on your chlorine type and the type of pool you have. You know, the thought process goes, and it's actually kind of funny as an aside. I got a really cool email from a homeowner and he's an engineer. And I knew based on the email, he was an engineer before he even said it. But in his response to my response, he said, well, as an engineer, I really like detailed responses. And I know you're listening to this, so thank you for that. Glad we talked about it. I called him back because I said, man, you really got me thinking. He basically asked, I need to understand your thought process for how you pick an ideal calcium and alkalinity so that you can contain pH. He didn't ask, what should my calcium and alkalinity be in Phoenix, Arizona, where he lives? Because I would have said probably low 300s on calcium and about 60 alkalinity. But that's because I do it every day. It was a great thought exercise because I had to write out each step of what I do with the calculator to figure that out. Well, now I just know it intrinsically because I do it all the time and I just have that gut instinct now. So he's got a saltwater pool in Phoenix, Arizona, no cover, and a little bit of turbulence from a spa overflowing into the pool. And I said, okay, you should have about 300 to 320 calcium in the summertime and about 60 alkalinity. And I went through and I started jotting down my thought process, like everything. Turn dial here, look at pH ceiling, adjust alkalinity, check CY, everything in order. And I just stopped counting at 42 steps. And I realized this is a really convoluted way of thinking, although it's so clear in my head. And if you do it all the time, it makes sense. Go in my ear and out the other, and you'll get it. So how do I convey that to you? And I'm going to try my best right here. Just think about two things above all. The first thing is, what is the coldest water temperature your pool is going to experience? For those of you in the Midwest and the Northeast, you already know it's freezing temperature. It's 32 degrees Fahrenheit or 0 degrees Celsius. Base your first decision on that. And then the flip side to that question is, what is the hottest temperature? Because the real question is, what is the temperature delta that your pool is going to experience? What is the swing, right? Is it going to be 88 degrees in the summer and 40 in the winter? What's the worst case scenario in either direction? That's your starting point. That right there is going to give you most of your calcium answer. As for alkalinity, that's really more of a question on your chlorine type. If you're using trichlor as a primary, which we do not recommend as a primary, it's a nice secondary, but it's really not meant to be a primary. You need more alkalinity. You probably need 80 to 90 alkalinity because you have an acidic chlorine that is constantly burning through alkalinity and the smoke is carbon dioxide. So you need more alkalinity in there to buffer against that chlorine. But what about a salt pool or a cal hypo pool or a liquid chlorine pool? What do you do about those pools? Well, in those pools, you have lower alkalinity, like 60. And if you're going to have that 60, you need to have enough calcium hardness to buffer against that. So if you're going to reduce your alkalinity, you got to raise your calcium hardness. So the way I think about it is, what is the temperature extreme and what is your primary sanitizer? From there, maybe put one temperature on the left side of the calculator and the other extreme temperature on the right and start playing. Figure out what you can do. And just understand, if the temperature swing is more than 40 or 50 degrees, you're probably going to need two different calcium numbers. You're going to need to boost it up in the fall. Because if it's a temperature swing of 50 degrees, your pool's probably freezing. That's a really big swing. But for a lot of people, that's real. And that's okay. You're not alone. If you don't want problems to come back like calcite crystals, you should definitely be putting enough calcium in your water. I had these grand plans for this episode when I sat down. And of course, now that I'm here, I'm not really remembering all of this, but I think it would be good to just touch quickly on what calcium hardness actually is. We measure calcium in our water as calcium hardness. Calcium hardness is expressed as parts per million of calcium carbonate. But technically, calcium carbonate is not really soluble. So what are we actually measuring? We're actually measuring calcium ions. And those ions are called cations because there's two protons on it. What happens is elemental calcium, Ca, has two electrons on its outer ring that get lost pretty easily. I'm paraphrasing. For the chemists listening to this, sorry. I'm just trying to distill this and simplify it. It loses two electrons so that it becomes net positive. So it's Ca++. That means it's a cation, but we're just going to call it calcium ion. It's looking for anions. It's looking for things with two negatives. The main one, of course, is carbonate, CO3 --. So Ca++ really likes CO3 --. But there are other anions. In fact, calcium can bind to bicarbonate, which only has one electron. And it can bind to sulfate. It can combine with phosphate if the conditions are right. So you get these other compounds. It's not just calcium carbonate. You can have calcium silica, calcium sulfate, which we talked about in episode 104, calcium phosphate, which is rare unless you have really high phosphates, really high temperature, and a lot of calcium. As an aside, I have never seen calcium phosphate in a residential pool. In going on 7 years of being with Orenda, I still haven't seen that. Calcium flakes in a salt pool are not calcium phosphate. They're calcium carbonate. Calcium phosphate is like khaki colored, and I have seen it before several times, but it's always on commercial pools on cal hypo feeders that are heated over 90 degrees. And it's usually in the filter or the heater. And it's like harder than concrete. You literally have to jackhammer the sand bed of a commercial filter and cut it out of the room because you just can't dissolve it. That's calcium phosphate, and hopefully you never have that. But the point is, calcium ion in any of those forms is going to pick up on a calcium hardness test, but it's expressed as calcium carbonate. And my understanding of this is because the molar weight of calcium carbonate is really easy to compare to water. So it's a great way to measure parts per million. Oddly enough, total alkalinity is also measured as parts per million of calcium carbonate. Kind of crazy, but again, it's a molar ratio thing. So don't get too confused on that. The point is, when you're measuring calcium hardness, it's calcium ions in any of those forms, as long as they're in solution. If you have precipitated calcium carbonate, like scale on the tile line or flakes, those are not in solution anymore, and therefore they will not be picked up by the test. So yeah, that's your 101 on calcium. So I hope that helps. But here's the whole point of doing this. If you want to have less problems and less risk of discoloration on a plaster surface or fading of a vinyl liner or the chalking of a fiberglass pool, which we'll do an entire episode on that too, have enough calcium in your pool. Water's going to be hungry for it. You might as well feed it. Adjust your alkalinity accordingly after that, because the more calcium you have up to a certain point, the more options you have. If I only have 250 calcium in a pool, I can't really afford to lower my alkalinity enough to contain pH at a reasonable pH ceiling without violating the LSI. It's really hard to do. But if I have abundant calcium, I can afford to lower my alkalinity down to 60. And my carbonate alkalinity could be lower than that because I have CYA in my water, or if you're using borate, all of those things lower the carbonate alkalinity. You can do that when you have a good enough foundation of calcium. I've said it twice already in this episode. I'll say it one more time. Calcium is the bedrock of water balance. And I hope you remember that. I hope this episode has been helpful for you. I don't know what your action step is going to be after this, but hopefully it sounds something like this. I need to have my guys test all of our calcium hardnesses and write them down. And maybe you can start standardizing your pool just by getting calcium hardness in line based on where you are. That's a huge start. That's a really, really good idea. Start ruling your pool. Get calcium to where it needs to be. And if you have questions on how to do that, check out our help center, ask.orendatech.com. Check out our blog, blog.orendatech.com, or just our website. Find it on the navigation bar and search the word calcium. We have a bunch of articles and procedures about it. You can also email podcast@orendatech.com, but check the help center first. Check the blog first. It's a quick search bar. See if we've talked about it. And if not, please do let us know, because we are always looking for great information. And to those of you who do email us and give us feedback and ideas for the show and pointing out issues with the app or typos on the website, thank you. I mean that. Thank you. It means a lot to me personally for the amount of effort that I put into this show, that you are still listening, that you're getting value out of it. And I hope this episode is no different. We make this show for you. If you have a chance, give us a review. Give us an honest review. I don't care what the star rating is in the podcast store or Spotify or wherever you are, as long as it's honest. We really appreciate it. I'm your host, Eric Knight with Orenda. Take care, everyone.
Thank you for listening to Rule Your Pool, a podcast by Orenda Technologies. For more information on what we discussed in this week's episode, check the links in the description or visit www.orendatech.com.
I hope you find this show valuable enough that you tap that subscribe button and share it with your friends. You can also like us on Facebook and social media. And with our help, you'll be able to rule your pool without over-treating it with chemicals and wasting money. I'll see you next episode.